Yes, today we're going to solve particle in a box. We have here the time-dependent Schrodinger equation, and it says that it's equal to the Hamiltonian times psi. First, what we're going to do, we're going to solve for this equation, and we're going to write it in this form like this, of x and t over the partial of t, and this is equal to the Hamiltonian, which is negative h bar squared over 2m times the partial square of psi with respect to x and t, position and time, over the partial of x squared plus b of x and t. Now, what we see is that what we have is a partial differential equation, second degree, and they are very tedious to work. So what we could do is find if this is a separable differential equation, and the way we're going to go about it is that we're going to say that psi it's going to be equal to the product of two functions. One side of x and the other one capital T of small t. And what we're going to do, we're going to place it in the equation and see if it is a separable differential equation. So what we're going to do is we're going to write the equation I h bar, and then what we're going to put right here is side of x times the partial of capital T of t over the partial of t. And this is going to be equal to, we're going to write this in this form like this, negative h bar squared over 2m and times capital T of t times the partial square of psi of x all over the partial of x squared plus over here we're going to have the potential as a function of x psi of x. Okay, this right here. And the way we're going to do is we are going to move this capital T of t over here and this side of x to the other side, and it's going to be I h bar over t of t times the partial of t of t over partial of t, and this is equal to, we're going to take this t out, this side of x out, and we're going to move it to the other side. It's going to be 1 over side of x times, no bracket, negative h bar square over 2m times the partial square. And what I'm going to do is I'm going to move everything as the partial of x squared plus my potential b of x, and this is going to be all times psi of x. And right away, if this side here, the time dependent, this side over here, is telling me that it's equal to this over here, this over here is equal to all of this over here. Then telling me that all of this here is equal to a constant. All of this here, if it's equal to the right side, it must be equal to a constant. So I'm going to write this. First, we're going to find for the time dependent. It's going to be I h bar over t, capital T of t. And now what I'm going to do, since t depends only on small t, I no longer need to take the partial because there's no other variable. So I'm just going to take the derivative of capital T of t over dt, and I'm going to call this constant E. So what I'm going to do is I'm going to come over here, all the way over here, and then go all the way up, and I'm going to solve that equation right here. And I know that I have this here, right on top of the capital T of t, the function. So what I'm going to do is I'm going to move this top to the right side, and I know that it's going to be, I'm going to integrate, but first I want to move this. So it's going to be the integral, right, of d as the natural log of t of t, and this is equal to negative I e, right, over h bar, and since I'm integrating with respect to dt, I know that I'm going to get that this is equal to the natural log of t of t of t is equal to, if I integrate all of this right here, I'm going to get this is negative I E T over H bar plus a constant of integration. And now I know that I can use my base E right here and use it over here. I can eliminate this, and I know that my T, capital T of T, as a function of time is equal to E to the negative E ET over H bar. And I have this constant right here, C1. What I'm going to do is, this is a constant, right? I'm just going to put it right in front, right here. A. And that is my time-dependent Schrodinger equation right here. Then, what I'm going to do is, I'm going to solve now for this part right here. For this part right here. Okay, and right away I know that I have this here. This also here has to be equal to a constant. 1 over psi of x times negative h bar square over 2m this square over d x square plus b of x and psi of x. This must also be equal to a constant that I'm going to call E. And what I'm going to do right now, I'm going to stop for now, and I'm going to do another video where I'm going to solve this equation. Because remember, what we want to solve is the particle in a box. We want to know what the energies are, what the eigenvalues are, what the eigenfunctions are. All of that we want to solve. So if you like this video, please hit like and subscribe. Thank you.